To our final presentation of the 2026 summer session of the Biomass webinar series. It is a pleasure to join you this afternoon. My name is Emily Heaton, and along with colleagues at the University of Illinois and Iowa State University, I lead the Biomass webinar series each year. Well, so far for the last 2 years, and I guess we can decide together if we want to keep it going. The Biomass webinar series is brought to you by a series of funded federal projects, including CABI from the Department of Energy, the Diverse Corn Belt Project from the USDA, and then a series of private funders through iRegion. There are several different institutes at our universities associated with the webinar series, representing how broad ranging the interest is in biomass for products and fuels. I want to make sure to remind you that we have our first International Miss Campus Summit that we're hosting here in Illinois this October. You can register for all 4 days if you want, or you can register just for the research days and just for the industry days. It's very affordable. Abstracts submission is open right now through August 10th. So we'll have poster sessions and presentations, and we'll have an industry trade show. So please register and join us. I am delighted today to introduce Ty Miller, who is wears many hats, I think, right now at the University of Iowa Facilities Management, but has been our liaison on the biomass fuel project for over 10 years now, working on Miscanthus in Iowa. So Ty, thank you so much for joining us today, and we're really looking forward to what you have to share with us.
Yeah, thanks for the introduction, Emily. Appreciate it. I'll try to share my screen here. Can we see that okay?
Looks great.
Yep.
Good. All right. Hi, everyone. Welcome. Like Emily said, my real name is Matthias Miller. So you see my email address is matthias-miller@uiowa.edu. I go by Ty, senior air utilities engineer here at the University of Iowa. Let's see, in October will be my 30-year anniversary working here in one capacity or another. So I'm 49 years old, but around here I'm an ancient fossil. So here to talk about our fuels procurement kind of philosophy strategy here at the University of Iowa. So I'll dive right in here. I'm going to whip through a little bit of University of Iowa background, give you a little bit of information on our utility system, kind of dive into our fuels philosophy, and then each of the fuels where we work with, I'll give you the pros and cons, and then we'll kind of wrap it up. So University of Iowa, comprehensive research university, large hospital, 30,000 students, almost 19,000 employees, most of them hospital related, 2,200 acres of campus. Whip through a quick little virtual tour here. A section of our university hospital, Papa John Business Administration Building, downtown area, communications building, water tower, medical arts campus, what we call the Penncrest, kind of middle of campus, old Capitol building, biomedical research, Stead Family Children's Hospital, our lovely smokestacks in the background there, Hansher Auditorium at night. So with all that going around campus, we use quite a bit of energy. Our annual energy use is pretty close equivalent to 42,000 average Midwest homes. Essentially the same as the surrounding town of Iowa City. So we're going to dive into the utility system here that keeps all that going. Here's a picture of our power plant. When I speak of the utility system, we got the power plant. We're producing steam for various uses around campus and kicking out a little bit of electricity from there. We also have a number of chilled water plants for building cooling. We get roughly, on average, roughly about 2/3 of our electricity from the grid, and we distribute that across campus. And we also have our own water plant, taking Iowa River water and turning it into drinkable water. So here's kind of a simplified diagram of what we're up to in the utility operation. We're here to talk about fuels today. So energy in the primary fuel is converted to steam. Steam passes through turbines, makes electricity. Steam leaves the turbines and goes out to heat and cool the buildings. We use the steam to run chillers so we can cool the buildings that way. So what we're going to talk about and concentrate on today is the main power plant, main campus. This area in red here. This graphic's a little out of date. We have one more gas boiler than indicated here and two solid fuel boilers, three electric steam-driven turbine generators, and four generators that are for backup emergency use, keeping critical electrical loops online in the event of an emergency, diesel generators. So at the power plant itself, our capacity is 755,000 pounds an hour of steam at 500 psi, three natural gas boilers, like I mentioned, and two solid fuel boilers, which we'll concentrate on today, and one that can also burn gas. We do have a number of remote auxiliary boilers that I won't go into today, but they help us out in different situations. Our electrical generation capacity from the power plant is 29 megawatts. As I mentioned earlier, typically we're only making about one-third the electricity that we're using on campus. What we do is kind of follow the steam load. So the steam demand out on campus drives how much electricity we're producing because the steam on its way out is passing through the turbines, generating electricity. Our total campus peak electrical demand is 70 megawatts. We tend to hit that peak in the July-August timeframe. If we have a steam-driven chiller out of service and we're running more electric chillers, we'll hit that peak of 70 megawatts kind of in those hot days. Our annual fuel budget is roughly 20 million, but last couple of years I've come in well under that number, so I'm pretty sure they're going to claw back some, and that number will be lower next time I give this presentation. Two solid fuel boilers. So two different technologies. One's a 1970s era Stoker boiler, pretty simple, relatively simple. Traveling grate on the bottom. Coal comes in one side, it burns, and it comes off the other end of the grate as ash, and it gets whisked away. These boilers are pretty particular about the fuel they can burn. There's not much optionality there. On the other side of the spectrum, we have you'll hear me talk about a CFB, a circulating fluidized bed boiler. And what we're dealing with here is essentially a suspended fireball suspended by air. And this thing can burn all kinds of material. But the key with this unit and others like it is it requires a certain amount of ash to circulate around in the boiler to carry the heat around for heat transfer. And we'll get to that a little bit more here in a little bit. So two different boiler technologies, two different solid fuel boilers in use at the main power plant. So just to kind of whip through here and give you the summary of what I just went through, we're taking fuel, we're combusting it in the boiler, we're turning that water into 500 psi steam, we're passing that steam through turbine generators. Those generators are kicking out electricity at campus. We're also purchasing electricity from the grid, and the steam off the turbines goes out to campus at two different pressures for various uses around campus: heating, cooling, processes, research, and then a very large sterilization operation associated with the hospital. And then we're here to talk about the fuel. So sometimes I give this presentation to people outside the Midwest, and I need to remind people that Iowa winters are extremely cold, so we use a lot of energy keeping everybody warm. Iowa summers are very warm, so we use a lot of energy keeping everybody cool. When we talk about fuels, we do have a lot of programs. It's not just procurement, but it's also being efficient with that fuel. So one of the ways we do that is through cogeneration, which I've kind of mentioned already, but essentially we're not using any extra fuel to generate electricity because the grid can do that cheaper for us. It's cheaper for us to purchase electricity from the grid. But what we are doing is generating electricity that follows the steam demand through the turbine. So we're just kicking out about one-third electricity from our main power plant. So cogeneration. Also in the fuel efficiency realm, we have a number of programs that we work with dealing with efficiency at the building level. The one noteworthy here is a brand new department. We opened up asset optimization services, and their job is just kind of building efficiency stuff, getting certain things worked into capital projects, our design standards, and then going back and recommissioning efforts of old buildings, things like this, to keep our fuel usage down ultimately. So back on fuels, one point I want to get across here is I'm not sitting here saying every college campus should be doing what we're doing. This is the greatest thing ever. Come follow us. Every energy district will have their own priorities. All I'm doing is saying what's been working for the University of Iowa the last few years. We seek to balance a number of interests in our fuel selection and procurement and our planning for off coal. Our particular community places a priority on renewable fuels, but we also understand we can't do anything to jeopardize our reliability and resiliency. A lot of research going on campus in that hospital. We like to not give them any hiccups, so we can't jeopardize their operations. So last, I'll call it 15 years or so, our fuels philosophy, we're committed to multi-fuel strategy. You'll hear a lot of folks just switching to 100% natural gas to get off of coal. For us, we never really considered that a viable option. We do have capacity concerns with gas coming into town, and also the pricing volatility gets us sometimes. And we do take measures to hedge against that, but it still gets us sometimes. So we use solid fuels to function as a hedge against natural gas supply issues or interruptions or pricing volatility. For our university, replacing coal makes the most significant environmental impact. So we were handed down a goal a number of years ago to get off coal by 2025, with the caveat that that transition must be conducted economically, which is the tough part. And then again, the reliability and resiliency of the utility system can't be compromised. So we're balancing a number of interests in our fuel selection, available technology, reliability of the utility system, economics, sustainability, and stakeholder expectations of the local community. So our overall strategies we embarked on a number of years ago was to convert our two solid fuel boilers. I mentioned we call them boiler 10 and boiler 11. We'll convert from coal to renewable fuels. And we looked at a number of options over time, number of experiments, but we settled on three fuels to replace coal: old holes, convergent fuel, engineered fuel pellets, and miscanthus grass. Uh, Generally, wind and solar, we get a lot of questions about that, but we leave that up to our utility operators on the grid, Mid-American and Alliant Energy. Um, for us, it doesn't necessarily help us replace coal because electricity only counts for roughly 25% of our energy use. The other 75% is all thermal energy, heating and cooling. I just want to mention real quick, we have two campuses. Our main campus is supplied by Mid-American Energy, and they earned about 96% renewable last year due to their wind farms. And Alliant Energy, we have a separate, smaller research campus in a neighboring town, Coralville, Iowa, we call Oakdale, and they get electricity from Alliant Energy, and they're 45% renewable. So back on fuels, our current fuels and use of the UI I'm going to touch on today: engineered fuel pellets, old holes, miscanthus grass, and of course, coal and natural gas. I think we all are aware of the advantages and challenges with coal. Well, one thing I want to hit on is it's energy dense. You can cram a lot of energy into the back of a rail car, so that's what makes it, I guess, attractive to folks. And that's the energy density will come into play here as I move on through this presentation. But here's our trend line on coal usage. We had a goal to get off coal in 2025. If I took this farther back, historically we were around 700. It fluctuated a little bit. We were between 70,000 and 100,000 tons a year of coal prior to 2015 timeframe. So we've been gradually trending down, working our way down there. Though that year, fiscal year 24 and 25, either we didn't quite hit zero. We could have, but we did have a couple of supply issues under a previous fuel pellet contract. And also, I do keep an emergency stock of coal on the ground. We have a fuel yard about a half hour away from campus along the Mississippi River, and I keep roughly 10,000 tons of coal in inventory over there for emergencies, and we have to keep that moving sometimes or move it around. So we do burn it every now and then. Fiscal year 26, we did not burn any coal. I don't know yet if we will this coming winter. Well, there's a chance we will if it gets really cold, January and February, because we're operating under a previous supply contract that doesn't quite give us enough volume for those really cold days. But last year we were at zero. Um, Moving on to natural gas, there's another one I think everyone kind of understands the pros and cons of natural gas. But for us, the challenges with natural gas are local capacity. There's not, uh, so if we were to add one more solid natural gas boiler to our fleet, we're looking at major pipeline improvements to the area and huge capital expenditures that we're kind of not quite willing to bite off yet. So capacity is an issue for us, and also the extreme pricing volatility in natural gas. Uh, winter storm down in Texas can send prices skyrocketing for a couple days. And if we're in the daily market at that point, you can see bills that'll hinder your whole operation for a couple of years. So we try to stay away from that volatility and manage it as best we can. And part of that is sticking with some solid fuel strategy. So for next steps in natural gas, we're just going to keep using it as we have been. We're going to gradually reduce as we work more fuel pellets into the system. We have not pursued a strategy of switching to 100% natural gas, but focus on development of a diverse portfolio. So I'm going to move on to engineered fuel pellets here. So we work with Convergent Energy out of Green Bay, Wisconsin. They produce a fuel pellet through a couple different streams, primarily fiber and paper material, some clean plastics and biomass that we're dropping off to them. So the non-recyclable feedstock materials in these pellets, I got a little list here, but it's pre-consumer waste, non-recyclable products from a factory. So you'll see non-woven polyethylene fabrics on there. So think about surgical gowns a hospital uses. There's a factory making those. They have all kinds of waste coming out of those factories that they previously landfilled that we're diverting into a fuel pellet um, and burning in our boilers in place of coal. The so these firms that are dropping off these pellet feedstocks, we're taking them to a landfill and paying a tipping fee there. What Conversion is doing is charging them less of a tipping fee to drop it there. So they're taking in that tipping fee, and that piece is what allows this fuel to be economical and cost comparative to coal and natural gas. So that's kind of the non-recyclable feedstock materials, and then we're also adding miscanthus grass and old hulls, which I'll get into here in a second. There's a picture of the fuel pellets, what they kind of look like when they get to us. These, if I remember right, have a roughly 10% of miscanthus incorporated into them. They're designed to be a drop-in replacement for coal. They're low in emissions and pretty high energy. The BTU content per pound is very equal to coal. Low ash, low moisture. There's kind of a number of benefits here, but the big one here is these ones I have in bold. The low capital cost to implement. We spent $0 on capital getting this fuel, capital projects getting this fuel. They were switching over from coal to this product, which was kind of nice. We're able to meet all of our emissions requirements. And here, the big one that the accounting folks around here like is there's no volatility in pricing. We just a month ago signed a 10-year contract. So we with Conversion for a local pellet facility within 100 miles of Iowa City. And that price is locked in and known. The annual tonnage is known for 10 years out. So that comes in pretty handy to the budget and accounting folks. Zero volatility. So why engineered fuel pellets? What are the advantages? Consistent pricing I already mentioned. Uh, I'm going to get to old holes and miscanthus in a second, but with that CFB boiler, and recall I said it requires a certain amount of ash to move heat around in the boiler for it to work properly. Old holes being our cheapest fuel, we cannot burn those without something else in there making more ash for that boiler to work properly. So that has to be coal or something else that can generate that ash. For us, it's these fuel pellets. They allow us. So what we're doing with the old holes is pneumatically injecting them into the boiler. It's moving around with the ash from the other solid fuels. If we were just operating on old holes, the boiler would not work properly. There's not enough ash out of the old holes. So hopefully I'm making sense, but these pellets let us burn old holes because they contain a little bit more ash. And they also are a vehicle to get miscanthus into the boiler. It's like I can't get miscanthus out of the field, and just drop it on a coal conveyor and let it go in the boiler and think everything's going to work right. I have to do some level of processing to get that material into the boiler. And for us, it's these pellets to get that incorporated and utilize the miscanthus. Another big one here. I'm sorry. Another big one here. I didn't highlight, but it is kind of a big one. We can customize the quote unquote recipe of the pellet. So there's a number of feedstocks that come into these things. And so in the early days, probably been 10 years ago now, we would in our stoker boiler, we would see slag formation on the sides of the boiler. It would gather so much weight it'd fall down on the traveling grate and cause us issues. So we grab a piece of that slag out, we send it off to a lab, get it analyzed. We learn it's different various aluminum oxide compounds. We hand that back to convergence. Hey, this is giving us issues. They find the offending feedstock, pull it out, and we don't have that problem anymore. So there's a little bit of ability to adjust the recipe as needed to fit combustion characteristics we need. So that's come in handy. Drop in coal replacement, better emissions than coal, divert materials from landfill, and like I mentioned, it is cost competitive, which is just a big one for us. What are the challenges with fuel pellets? It's not all peaches and cream. There is a perception of combustion of plastic. If you most people when they hear burning plastic, they're thinking of a 20-ounce Mountain Dew bottle getting thrown on a campfire, black soot, this sort of thing. And then scientific folks will point to dioxins and furans. I'll probably butcher it, polyaromatic hydrocyclic carbon, something or other. They'll point to this sort of stuff, known issues with plastic combustion. So what we did early on was work with our College of Chemistry folks and a couple of stack testing firms. Have instrumentation they can plug into our smokestacks and see what's coming out. And we looked at dioxins and furans and plastic combustion byproducts. And what we learned was if we burn at the right temperatures, a high enough temperature, these things are not an issue for us, and the emissions are indeed better than coal. But that public perception is a challenge we have had to overcome. You are reliant on factory production, like logistics. Factories do break down; they do have issues. Trucking logistics coming out of Green Bay is troublesome sometimes. Slight variability in available feedstocks. These firms supplying these feedstocks to Convergent will come and go. There'll be a little bit of moderate variability over time, but nothing insurmountable. Volumetric constraints. So I mentioned the pellets run about 11,500 BTU per pound, which is very similar to a lot of coal from around the country. But the BTU per cubic foot is about one third that of coal. So you'll run into volumetric constraints without big capital improvements to the boiler. So, for instance, our Stoker boiler has certain feeders on the front that were designed for coal. They fling the coal out onto the grate into the furnace, and we get volumetrically limited through those things because just the heat content per cubic foot is less with this stuff. We determined we were able to get high enough load out of the boiler. We took a moderate hit on boiler capacity, but we weighted against the additional capital to put new feeders on the boiler and just determined it wasn't worth it. We just took a slight reduction in rated capacity of the boiler and took off with it. So just something to think about, volumetric constraints there. Long-term storage, you can't really do it outdoors. It weathers, rain and sun break the product down, so that can become an issue. And then chlorine content. So we had existing emission controls in place for coal that went after hydrochloric acid emission, essentially dry sorbent injection into the flue gas stream, leaving the boiler that knocks out that HCl component. That same system is in use with the pellets. So we didn't have any capital expenditure there. It's the same emission control system as we had on coal. Here's a quick little video of what the pellet burning looks like in the Stoker boiler. So what we're looking at is into the furnace. The grate's traveling toward us at a very slow rate, and the pellets are getting flung out into the flame. It travels towards us here in this video, and the ash falls off the end of the grate down in some ash hopper. So that's what the combustion looks like in the Stoker unit. What's our next steps for the fuel pellets? Well, like I mentioned, we're developing a local pelletizing facility. We think it's going to be somewhere along Interstate 80, not too far away, but we're not quite sure yet. We went under contract about a month ago, got all that finalized. That was a long, long time in the making, but we're there now, and we got a 10-year deal, and the pellet facility is moving forward. We want to continue to improve the process to utilize miscanthus in these pellets, and I'll get to that in a little bit. And then we've been experimenting with torrefied fuels for a while. Once we get this new pellet plant up and running, we're going to kind of return to that. So a lot of you might be familiar, but it's essentially heating up the product and turning it into some form of carbon, heating it up in the absence of oxygen. So we've been playing around in that realm. We haven't been able to do it economically yet, but I think there's plenty of opportunity there. And it would allow us to take additional feedstocks and decrease some of our emission controls component because that chlorine component comes out in torrefaction process. So we wouldn't have to worry about our emission control. Um, So now so that's the fuel pellets. I'm gonna move over to our biomass components now and kind of go through our old holes in miscanthus program. This statement seems a little bit like Captain Obvious, but for us a while back, we kind of had to learn this when we first started looking at biomass. When our administrators told us to get off coal, it was kind of, we're looking at sugarcane out of Louisiana, wood pellets out of Canada, and it just doesn't pencil out. We couldn't get the economics to work, so we determined relatively early on that this stuff needs to be local for it to work for us. So we moved over to up the road in Cedar Rapids, about a half hour north of Iowa City's a facility, Quaker Oats. They're making granola bars, cereal, Captain Crunch, things of that nature. And they have this old whole byproduct. They have a number of byproducts, but the whole pictured there on the right is the one we get from them that they were previously landfilling, but we came up with a system to pneumatically blow it into that CFB boiler. So we've been burning since 2003, roughly 30,000 to 40,000 tons per year. We could do more if I could get some more storage, but we haven't been able to prioritize that through capital expenditure quite yet. But our current volume displaces roughly 1,000 truckloads of coal a year, with just getting old holes into the boiler or CFB there. And it's a nice local industrial byproduct. So why old holes? It's renewable, consistent pricing. This is another one of those. I typically do these in 3 to 5 year contracts, depending on what Quaker wants to do at the time. But it's a stable price and a stable supply, which again accounts like displaces coal with much better emissions, and it's a local source, so we don't have much shipping and diesel fuel costs associated with it. What are the challenges with old holes? We do require specialized trailers for transport. I won't go into that whole lot. We could probably overcome with some capital expenditures, but right now we're using specialized trailers, which can drive up the cost of transportation a little bit when you only have one or two bidders on those transportation contracts. But and this is another fuel. I can't just put it on a coal conveyor and try to get it in the boiler and hope it'll work. It's so the system we have is we pneumatically blow it into the CFB boiler, and it kind of looks more like a natural gas flame coming out of there. We're shooting these oats in at a high rate, and you wouldn't be able to distinguish it from a natural gas flame. And they're burning on impact, and the flame is doing what it needs to do there in the boiler. Another challenge is, oh, and I should mention too, we have and can pelletize these in different. We've done it in different manners, but they do work pretty good in the conversion product. It makes a really solid fuel pellet. Uh, Another challenge is you're relying on factory schedule. There is supply interruptions. They do have shutdowns at Quaker. They have scheduled shutdowns, and then your typical emergency stuff. And one of their shutdowns is a month long in the wintertime, right in our highest steam demand area. So that's something we deal with. And sizable storage is required for these. Like I mentioned, I could use a couple more silos on site, but we just haven't been able to prioritize it yet. What's our next step with old holes? We're just going to maintain. We got it on autopilot now. We're going to keep with the long-term contracts and keep pushing to increase storage offsite and onsite to help us overcome those periods of we're getting not much supply out of them, and intermittent feedstock for a local pellet plant. We're blowing them in our boiler, but when our boiler is down for maintenance a couple times a year, or if Quaker has an uptick in production for a couple months for whatever reason, and they have more oats than we can burn at the facility, then the idea is to divert this fuel to the local pellet plant and get it put into the pellets at that point. So it'll take the form of intermittent feedstock for the fuel pellets, with the preference being to just doing what we're doing now, pneumatically injecting them in the boiler when that boiler is available. So I'm going to move on to miscanthus grass now. This is a little bit different for me because I'm used to giving this talk to folks who've never heard of miscanthus, so this is a little different. I'm not going to spend a whole lot of time on yields and rhizomes and things of that nature because I'll probably sound kind of dumb to you research folks, but we'll see what we could do here. Our program is a partnership with Agrotech, Iowa State, University of Illinois. We've been at it for a number of years. We planted 1,100 acres since 2015, and miscanthus is one component in our diversified strategy. The question for us is how much value does a local renewable fuel add to the reliability and sustainability of a campus energy system? It supports our overall fuel strategy. It's another piece of the puzzle. It reduces our dependence on a single fuel source, creating optionality. But we're also supporting local and regional fuel supply chains, which is kind of a big deal for us in our local community. So why miscanthus matters to the UI? What are the advantages? Well, it supports fuel diversification. It's Iowa based, contributes to our sustainability and carbon reduction goals. The folks in our office of sustainability love the stuff. Provides economic opportunity for Iowa growers and logistical folks. It's a perennial crop, no ongoing establishment costs. Iowa, of course, conducive to agriculture. Um, Travis Hedrick with Agritech, I think he's on the line here. They've been gotten pretty good at harvesting, pretty efficient process there. Uh, Grows on marginal land, which is a big deal. High seasonal growth rate keeps our spend local economy and all the environmental benefits it brings along with us. We're sequestering carbon and we got the research folks looking at nitrogen uptake and things of that nature. Emily, I think I plagiarized one of your pictures here from one of your experience around Ames, but I'm not can't quite remember where that one came from. And of course, erosion control and water quality concerns. So why miscanthus? What are the challenges? Land requirements. It can be expensive to ship unless it's densified in some manner or in that pellet. The harvest cost is tied to the price of diesel and the distance between our farms. When we first started procuring or getting leased farm ground, there wasn't a whole lot of opportunity to centralize with the locations. So we're a little bit sporadic around our area, so that can drive up costs a little bit. Require some form of processing for energy use. So our current path is putting it in that miscanthus pellet. And then storage and handling, we do require, right now we're using ag bags, but our new pellet facility will have sizable miscanthus storage associated with it. It's a seasonal harvest, so we're getting a lot of tonnage out of the ground over the course of a month or two, and then trickling that pile down throughout the year as we use it. So you do need sizable storage to accommodate that initial harvest and all the material that brings in. Picture of Miscanthus rhizome here. So about 10 years ago, Travis and Agritech were running all over the state, putting these things in the ground, getting our fields going. As I mentioned earlier, the harvest, Agritech has done very good over the years, honing that process for us and very efficient to harvest. It's not high moisture. And our current farms have kind of allowed us to kind of hone in that deal. Agritech folks can speak this more intelligently than me, but there's been a lot of trial and error on different drum designs, things of this nature on the harvester and different ways to do it. But I think where we're at now is a pretty good, pretty efficient process. And here's a quick little map of our fields. Here's Iowa City in the middle, and here's where our current fields are kind of located there, and the nature of them. A couple harvest pictures here, a little wintertime harvest going on. They run these carts alongside the harvester, put it in the carts. A little nighttime action. Use this reloader to put it in the back of pickup trucks and whisk it away to its destination. A little bit of ag bag action. And then this is a picture of our fields. We actually have a roughly 40 acre field right on campus. So that's kind of nice. Folks always want to come out and see what's going on out there when we're harvesting or doing stuff out there. And we do host a number of student groups and things of that nature that are interested in what we're up to. So we come out here and show them the crop, and it's kind of nice to have it so close to campus. So a quick little trivia question here. How many acres miscanthus would need to provide energy for average Midwest home for 1 year? Less than 1 acre. So that's pretty handy. A little bit of info there. Additional notes on miscanthus. So like I mentioned, we're waiting for that local pellet plant to get off the ground here, and we just did the contract a month ago. Working up to that, the cart got a little bit ahead of the horse. The miscanthus program got way out ahead of the pellet plant. So in the meantime, it doesn't quite make sense for us to ship undensified miscanthus all the way up to Green Bay. So what we're doing is sending a couple truckloads a week up there on an empty backhaul, just to kind of keep costs down. And the rest of the material we're putting out into emerging markets, animal bedding, erosion control, retail miscanthus-based products. Agritech folks can speak better than I on that stuff, but they're kind of fencing that stuff for us. But we're trying to get these markets, kind of support them, get them off the ground a little bit. Excuse me. Um, just while we're waiting for a local facility to take place, all that will be kind of fading away, and all the material will go to the new pellet plant once that gets off the ground. This doing it this way has kind of allowed us to keep on working the material, keep on conducting harvests, keep on getting better, finding efficiencies, things of that nature. Our current contract with the pellet company calls for 6,500 to 7,500 tons of miscanthus for feedstock. So that's roughly, excuse me, 10% by weight of feedstock going into the overall annual pellet amount. And then again, I'll mention torrefaction research. We're going to keep playing around with that once this new pellet plant's up and going. We're going to get back on torrefaction and see what we can do there with the miscanthus and gradually try to incorporate more higher percentages into the pellet. The issue we have now is about 10% by weight. That pellet can get a little bit crumbly. It's not out of hand, but it just gives us a little bit of difficulty in our conveyor. So we kind of cap it at 10% by weight right now, and then we're kind of working on ways to try to increase that percentage. So our next steps for miscanthus, you heard me talk about the local pellet plant. 10% of the fuel pellet can be miscanthus. Um, Testing ways to increase it. We'd like to do some work around increasing bulk density to reduce the cost of storage and trucking. This probably takes the form of baling, or right now we're getting out of the field in this 1 inch minus sort of spec. Maybe we can take the whole stock down and bale it and drop that off the pellet facility. We'll be working through that stuff, trying to keep shipping costs and things of that nature down, and then just continue improving harvest efficiency and logistics with our friends at AgriCheck. We want to take this opportunity there. We want to thank all the people that have been involved in our Miss Campus program over the last over 10 years. Appreciate everyone's help and pitching in here. And a special thank you to the research folks. We appreciate all the work you folks do and helping us out when we have questions and our constant collaboration. If anything comes up from you folks and you need our assistance, our fields, access, anything like that, please get in touch with me and we'll do what we can to help facilitate. And then our miscanthus grower, Steve Schomburg, I think was on the line here. Got a little picture here from Travis. Steve, thanks for all your help over the years and all the growers. We appreciate that and working with our program. Steve and Dan Black here were pictured. We're early adopters and they're really good ambassadors for the miscanthus program, what we're up to, and we appreciate them. Uh, Coming to the end here, we're just to kind of summarize what we're doing with our fields going in the future. We're keeping coal around for emergency use only for the time being. Uh, the new pellet contract will allow us to gradually reduce our natural gas usage. We're going to continue to implement programs for efficient use of fuel, cogeneration, building efficiency, things of that nature. The local pellet plant, continue fuel pellet innovation. Um, Long-term supply agreements, I've mentioned a couple times. Continue partnering with academic and industry experts like the folks on this call. If you're interested in working with us or getting access to our fields, you need a little miscanthus program for this or that, some experiments, please get in touch with me. We'll definitely do what we can to support what you're up to. And always our goal to minimize costs and risk for Iowa taxpayers. Uh, Overall, our fuel goal is to multi-fuel or increase resiliency with a multi-fuel strategy, keeping sustainability in mind and a fuel efficiency and maximize the economic benefit for our local economy through a local pellet plant and local pellet feedstocks. And that concludes my presentation. Thank you, everybody. Appreciate you listening.
Thank you so much, Ty. That was amazing. Um, we got a lot of questions.
Okay.
So before I jump into those, I just wanted to build on something that Ty just said there at the end. That was very gracious, Ty, the way you acknowledged all the people who have been lucky enough to partner with you over the years. But just from a taxpayer perspective, I don't pay taxes in Iowa anymore, but I did for 10 years. And I don't know of any project that I can think of that has been one of the more efficient ways that I know of to use taxpayer dollars. And I don't know many entities that have worked as well as the University of Iowa's facilities entities have had to be open-minded and undaunted about trying new things despite a lot of bureaucracy. So Ty kind of glossed over how heavily regulated this industry is, and for a good reason. But I just want to commend what sort of the groundbreaking and fearless way that the University of Iowa has approached this while just sort of casually getting stuff done. It was a very Midwestern approach, I think, to doing things. So as a taxpayer, I know you shared all the data that you can with us. So Andy Van Lukey and I use this to help inform recommendations, and it's one of the most seamless ways that I know of to get user-based information out to people. So we all thank you. Now to the questions. So Charath jumps in with the first one about oat hulls, which is what is the pricing of oat hulls and calorific value? I think some of us are just trying to compare oat hulls to miscanthus.
Yeah, sure. Let's see. The calorific value, those run about 7,500 to 8,000 BTU per pound. And the pricing, I don't have the exact numbers in front of me. I apologize, but typically we're going to be roughly one third the price of the of coal per BTU. Be a good rule of thumb there.
And just a quick follow-up, do you know what the oat hulls would go to if they were not going to you?
They in the early 2000s, it was all getting landfill, just mass amounts of trucks going to the landfill. They found some of the stuff is working its way into feed op like horse and cattle feed operations. But a lot of it gets landfilled. They have trouble kind of getting rid of it all. And we've actually had other old hole manufacturers get in touch with us wanting to get rid of their old holes, not Quaker. And we just don't have the capacity or the storage to work with them. But it is an issue that's out there. I think, I'm not intimate with the industry, but I do deal with them. I have a once a month recurring meeting with the Quaker folks, and um, a large majority of it's getting landfilled.
Great, thank you.
Mhm.
And then the next question is, what would happen if you attempted to make fuel pellets 100% from miscanthus?
We have done that. We do in the early days we did a lot of experimentation with switchgrass, prairie grass, miscanthus. We've used you know, diesel powered pelletizers on the side of the field. Um, I have made 100% miscanthus torrefied pellets with an outfit called National Carbon Technologies. I think they changed their name recently. They operate in kind of the foundry industry, but um, the issue is always is the cost because when you press the miscanthus through, 100% miscanthus through a pellet die to make a usable, stable fuel pellet, it takes a lot of energy to do that, to break down that lignin on the kind of the microscopic level and get something that kind of adheres and stays together. It takes a lot of energy and hence fuel to do that. So we haven't, we can do it. Just the scale we need and the cost of it isn't beneficial to us. So that's kind of one of the things that pointed us to this conversion product was it's a densified fuel, but it's held to get, it doesn't take near as much energy to get through a pellet die and get all those composites together in a cohesive pellet unit as it does a typical 100% biomass pellet. So that less energy required to make that pellet and also the tipping fee they get are both what makes it economical to us. So we could 100% pelletize miscanthus. We could 100% pelletize old holes. But it's just not, the cost isn't where we need it to be competitive with coal and gas. If that makes sense.
Yeah, that's great. And I think Doug had a follow-up question in here about binders. Do you need binders for the pellet? What is your experience with binders?
That's the predominant function of the plastic component in those pellets. We're taking certain plastic byproducts that burn pretty clean, and we're kind of melting that down and pressing it through a die, and that kind of becomes the binder. There's a little bit of proprietary information in there that you'd have to run to the convergent folks to talk to them about, but that's essentially what it is. There's no binders. In 100% biomass when we were doing those trials, we tried a few different things, cornstarch and a couple other things, but it all worked, but it just kind of added cost. But I'd say the
Thanks.
binder right now is that plastic material in our
Okay.
current pellet.
Other questions for Ty? I know we're coming up on 12:45, but we have time for a little more.
I got one for Ty.
Go ahead.
And
Ty, have you imagined any other pathways for material to make its way to your facility, like something that's even more circular? Like you could send off some stuff for erosion socks or plates and that kind of stuff that ends up making its way back, getting multiple uses and making the economics maybe work out a little bit better. Of course, it's more complicated. So have you had any thoughts about that?
yeah, one thing that's intrigued me in that kind of in that regard, Andy, is me and Travis with Agritech had met with the city wastewater for Iowa City wastewater department. We discussed a couple things. I know Agritech has a couple of projects in the works, but we're looking at if you could use the miscanthus as a poultry bedding, scrape that back in, digest it, get the gas off of that, get in the gas pipeline, things like that. I think are intriguing. The Iowa City wastewater folks are definitely intrigued by that sort of idea, and we're likely to have conversations with them. Right now, I'm working on a renewable gas offtake agreement with them. They just put a system in off of one of their digesters for some gas to clean up the gas off the digester and get it into the natural gas pipeline. And I'm going to sign an agreement with them to take 100% of that gas. It's not a huge amount right now. It's kind of a drop in the bucket with what we're up to at the university, but it's a good start and a good story. And it's going to kind of start that path. It's kind of the idea. If that makes sense. That's probably the main one in my mind, Andy, if that makes sense.
And I'm just putting a link in the chat for those of you who missed Rob Tripp's presentation last year from Polterra. That's one of the groups that's using miscanthus poultry bedding for digested gas, but there's, I think, also groups in the Netherlands as well. So that's an exciting prospect. So we are at time for today, but that same link in the chat is where you can find Ty's presentation, probably later this week. Ty, that was perfect. Thank you. I hope that you are able to join us in October, but otherwise we look forward to more good work from the University of Iowa, and thank you for sharing it with us today.
Yeah, thanks for the opportunity to tell our story. I appreciate everyone showing up, and good to see everyone. Thank you.
Take care, everyone. See you next year.
Have a good one.
John.
Much. Thank you.